So now we do have our game, and our game is working, and when we go and hit something, we are in this limbo state. The problem is we are going to be in this limbo state forever because we don't have a reset function. We're now going to build that very simple reset function so that we can reset our game. So to do this, we are going to go and find our game mode one more time. And I believe we put that in content, and here we can see our birdie game mode. If I open up our birdie game mode here, we're going to open our full blueprint editor, and in the top right-hand corner, we can see the parent class that we gave our game mode. We can see here that it's set up to be game mode base. And we don't want that to use this reset method that I'm using here. So to change the parent class of this little blueprint, we're going to go into class settings, and we're going to change the parent class using this little drop down here. And we're going to change this to not game mode base, but regular game mode. And then I'm going to compile and save. Now the next thing we're going to do is we're going to create a method within our bird that's going to be called whenever we get hit so that we can reset. So let's do that now. So we're going to go into bird.h, and we are going to be creating a public method here. The reason it's public is we are going to be calling this directly as an implementable event from Blueprint. So right here in our public section, I'm going to create a new line, and it's going to be type ufunction. And this is going to be considered a Blueprint implementable event. And then we'll set up the rest of our signature like normal. We don't want to return anything, and I'm just going to call this handle reset. Now, we don't actually want to create this within the C++ file because that would cause an issue because we are saying that this is going to be handled entirely within Blueprint. Now, the only other thing we need to do here is we're going to go into our C++ file here, and we're now going to add this function to the list of things that happens whenever we are going to have this hit occur. So whenever a hit occurs, we are going to be disabling gravity, making sure we don't tick, and then we are going to call handle reset. And then we're going to disable our input. So now we can save, compile, we'll close out of this, and then I'm going to open up my bird blueprint. And now here we're going to go and we're going to right click, and we are going to look for handle reset. And then we can see here that we have a new event called handle reset. Now, whenever reset happens, I want to go and I want to first of all say, I want to wait a few seconds. So I'm going to implement another delay, and I'm going to say, let's wait for 2 seconds. After those 2 seconds, we're then going to go and process our reset. Now, the simple way that I like to reset things is we're going to now use that new game mode instead of game mode base to make things happen. So dragging off of the completed node here, I'm going to look for something called cast to game mode. And what we're going to do here is we're going to basically take something that is a game mode, we're going to confirm that it is a game mode, and then we're going to be able to call a game mode function from here. So what do we want to plug into this? We want to plug in our game mode. So what we're going to do here is we're going to call for get game mode. There we go. So now we have our game mode, making sure it's a game mode. And then after we've gone and casted it as a game mode, we are going to call restart game. And then we want to make sure that our target is our game mode. So with all this plugged in, we're going to compile, we're going to save, and now I'm going to ram my head into the roof. We can see we fall around, and then after 2 seconds, we go and we have control of our character again. Now let's go and I'll show you what happens if I hit a pipe like normal here. So I'm going to go, oh no, the pipe, it's getting the best of me. There's nothing I can do here. I get bonked, 2 seconds pass, and I'm back and I'm reset. Perfect. So now we're going to start moving towards creating some sort of system to tell us our score. And the way we're going to do this is I'm going to create a little coin because I like visuals. So we're going to go into C++ classes, into our folder. We're going to right click new C++ class. This is going to be an actor because it's going to go in the world, and I'm going to call this my coin. So we're going to reload as normal, and now we're going to start filling out our coin. Our coin is going to be pretty similar to our bird, so I'm going to cheat, and I'm going to go and I'm going to get my components from my bird. So I'll create my new private section here, and I will paste these components here, and then I'll go into my C++, and I will grab my capsule component and base mesh setup, and I will make sure that gets put in our constructor. Now we do need to make sure we include our header file here, so I'm going to grab the capsule component header file, and I'm going to drop that into my coin. And now we can see we no longer get errors from our capsule component. Now next, we are going to want our coin to move in the exact same way as our pipe. I usually don't recommend this, but I'm just going to copy and paste the code that we have already made for our pipe. So I'm just going to copy this, and I'm going to paste it into the coin tick. So now we know, because we copied and pasted, that we're going to have this exact same movement. But that being said, we still need to create our movement variable. So into coin.h we go, and we're going to create another float. And this is going to be our move speed to match what we already know, and it's going to be equal to -100.f to match our pipe. So now everything's going pretty well here. I'm going to save this and then compile. And as we've done before, I'm now going to go and I'm going to right click on my coin. I'm going to create a blueprint class based on it. And then I'm going to call this BP underscore coin. I'm going to save that to my blueprints folder. Once this pops up, we have the same little system we've had multiple times before. For my base mesh here, I'm going to choose the static mesh of sphere. And then for the material, I don't know, something like gold sounds good. And luckily there is a metallic gold, so that just sounds perfect to me. I don't know how massive this is going to be in the world, but we'll find out in just 1 second. Let's compile this here. We're in our blueprints folder in our content drawer down there, and let's just drag in our coin and see how big this is. That is a relatively large coin. First, I should actually set up our capsule component, and I'm going to change my half height to be a little bit bigger, and I'm going to change my radius to just perfectly match that little circle there so that we're always going to be interacting with it. And then I'm going to take my scale, I'm going to lock it so it's uniform, and I'm going to make this like a quarter of the size that it currently is. That looks a little bit better. So compile and save that there. Now the only thing left to do is we're going to go into our spawner and make sure our spawner is also going to be taking care of our coin. So open up our C++ once more. Let's go into our spawner.h, and we're going to create something very similar to what we did with Big Pipe. We're going to copy it. I'm going to paste it below. And then this time, instead of it being the class a big pipe, this is going to be class a coin. And we're going to call this my scoring coin. Now inside of our spawner.cpp, we're going to go in and we're going to do something very similar with the coin. After we spawn our pipes, I'm going to create another automatically assigned variable that I'm going to call my coin. And then this is going to be equal to get world, spawn an actor, triangle, circle. Inside of our triangle, we know that this time we are spawning out a coin. And now we are going to do something very similar to what we did with our pipes. First, what are we spawning? We are going to be spawning our scoring coin variable. Next, we want it to spawn at the root component, and we want it to spawn at the current location that it's at, plus the variableness that we have in our pipes spawning. Next, we're going to make sure we set the rotation properly, and we're going to make sure that our rotation is set to our root component. And we're going to make sure it's properly set to this component's rotation, not location. And then we're just going to leave that as is. So now we're going to save this, and we'll compile, and we're going to get an error because we actually missed a step here. So always remember, just like me, you're going to have to make sure that you're always putting the header file for what you're referencing inside of the C++ file. So in this case, we didn't do that. So we're going to go into coin.cpp. We're going to copy our coin header file, and we're going to put that into our spawner CPP. Then we're going to save that there. And now we're going to compile, and I'm expecting to have no issues. Wonderful. Now we can go into our blueprint spawner, and we're going to need to set up that default value. So we're going to go in. We can see here that we now have a scoring coin available, and we're going to make that equal to our blueprinted coin. I'm now going to compile and save that. And now I'm going to delete this coin from our world. And now I'm going to hit play, and let's see what happens. We can see right in the middle of our pipes, we do have our little coin, and this is fantastic. We can now go and make sure that the collision and everything works. So what we need to do is we need to make it so the bird and the coin don't hit each other. We want to make it so they overlap each other. Now to do that, I'm going to go into my BP coin, and once my full blueprint editor is open, I'm going to be looking inside the capsule component, and I'm going to go to our collision section. And then we can see here that our coin is properly set up to be overlap all dynamic, which is what we want, because we want our coin to be overlapping with people, not blocking them. So now let's move this out of the way and let's just take a quick test here. So now as our first pipe approaches here, I'm going to go and I'm going to try and pass through my circle, and we can see that that fails miserably. What else could be going on here? So let's go back into our blueprints here, and I want to go and I want to check out everything to do with our BP coin. We know that we want to handle overlaps and collision within the capsule component, but we have not considered the base mesh yet. The base mesh might incorrectly have the wrong collision type set up, which could be causing our issue. So when I go into this base mesh section of my coin, I'm going to scroll down to collision, and we can see down here that this is the issue. We do have a collision preset for the base mesh that is set to block all dynamic, which obviously isn't ideal. So I'm going to go and I'm going to change this to no collision because I don't want my base mesh to trigger collisions at all. I want that all to come from my capsule component. So I'm going to compile and save that there, and I'm going to move this back out of the way. And now as our first set of pipes approach, we're going to quickly thread the needle, and we can see that we actually pass through our coin, which is exactly what we want to happen, and we still interact with the pipes in the same hard way. Excellent. Now with all of that out of the way, we're ready to actually go and start coding what we want to happen whenever an overlap event occurs. So let's go into our bird.h file here, and now we're going to go and we're going to figure out, similar to how we did with our on hit, we are going to create something that's going to help with an on overlap. Now, overlaps are a little bit different than hits because you can call an overlap start and you can call an overlap end. And you might want to do different things depending on which side of the overlap you want to calculate on. But for the sake of our purposes here, we are only going to be concerned about when the component starts overlapping with something else. So as we did before, here's the uPrimitive component page within the Unreal documentation, and I'm going to look for something called, I'm just going to search overlap. That sounds easy. Oh, but that gives a lot of results. So I'm going to look for overlap begin maybe. So let's do begin overlap. And there we go. Now we can see on component begin overlap. And if I click on this here, we can now see that we need to look for something called the F component begin overlap signature within Unreal to get the signature that we should be passing through. So let's close this out of the way and let's do what we did before and just paste that blank nothingness into our code here. And then I'm going to press F12 to search through to find our parameters. As was before, I'm lazy and I'm going to copy and paste here. So I'm going to copy and I'm going to go back into my header file here and I'm going to start setting up the function that I want to happen whenever I overlap in the beginning. So I'm going to make a new U function and it's going to be a void called onOverlapStart. And I'm going to just paste all the garbage that we found right into here and I'll top it off with a semicolon. Now let's set it up the same way we did before. We're going to go through one at a time and we can see here, this is the name of the signature, so we don't need that and we're going to get rid of it. This is where it comes from. We don't need it. We can get rid of it. This is what we're actually doing. We don't need it. We can get rid of it. Now this is the start of the good stuff. First, we're going to have a uPrimitive component called overlapped component and we're going to get rid of that comma so it actually looks like a proper variable declaration. Same thing with an actor here. We can get the other actor involved with the overlap. And then we have another uPrimitive component talking about the specific component that was involved in the overlap. And then we have an integer that talks about the other body index. And we have a Boolean that says from a sweep and a whole bunch of other stuff that I don't necessarily know what it means, but I know I need to include it in order for this overlap to work properly. And then as I've done before, I'm going to go and I'm going to create this within the C++ here by leveraging my little screwdriver, and I'm going to create the definition in birdcpp. I'm going to close out of this. I'm going to go into my C++ file. And then we can see here is our function on overlap start. And just to do the good old test to see if this is going to work the way we expect it to, I'm going to go and I'm going to create a UE log. And this is going to be a log temp. We want it to be a warning, and I'm going to make this say overlapping. So now all of this stuff here is only bringing in what we want to happen when an overlap begins. We're now going to need to do something very similar to what we did when we talked about what happens when we're setting up the onComponent hit. We're going to do the same thing now for this. And we're going to go through and we're going to access our capsule component, and we're going to call a method off of that called onComponentBeginOverlap. And then from there, we're going to do add dynamic. And then we're going to go through and we're going to say that we want this to then go and call our bird function called onOverlapStart. And then the last thing we need to do is we need to go back into our header file and play cleanup so that this does not keep bogging us down. Save and compile. Perfect. We'll close out of that. We're going to open up our output log, and now we're going to go and we're going to play our game. So now we have the moment of truth. Will our overlap fire? And we do. We can see we have overlapping that occurs whenever we start overlapping with something, which is fantastic. Now, usually we would want to do something to check what we're actually overlapping with, but within the scope of this game, we're only ever going to be overlapping with coins, so I'm okay with this. So now we can actually go in and we can code what we want to happen during this overlap. If we go back into our code, we'll go back into our C++ file, and now we're going to actually fill out what we want to happen when the overlap starts. And the whole point of having this coin in the first place was so that we could keep track of some sort of score. So we're going to finalize that idea now. We're going to go into our header file first, and we're going to create a new private variable that we're going to make an integer since it's just going to be flat numbers, and we're going to call this my score. And I'm going to initialize this to always be 0 in the beginning. So we've got our new variable with the score set to 0, but notably this is private, and we are going to want other things to eventually access this score variable. So what we're going to do here is we're going to do something I alluded to earlier called a getter method. So inside of one of our public sections here, I'm going to create a new method. Now this method is going to be returning an integer. So we're going to call it an int method, and we are going to call this getScore. And we are not going to be passing any parameters in to this method. So now from here, we're going to go and create our definition, and we're going to close our C++ file. And now we're going to go and we're going to go into our C++ file, and you can see we now have this basic setup for an integer method that is going to be our getScore. Now, since this is a simple method, we are going to put all of this on one line to save us some space, and we are going to basically return the value of our score variable whenever someone asks to receive the score variable. So now back to our overlap. Whenever we do overlap and start interacting with one of our coins, we are going to want to increment the score. So the way we're going to do that is we're going to say score plus plus. That's a simple line that says, take my current value and add 1 to it. Now, since we don't want people to potentially cheese this and interact with the same coin more than once, we're now going to get rid of the coin that did the interacting. Luckily, we have access to this because we have this variable here called the other actor that was involved in the collision. So what I'm going to do here is I'm going to call destroy on this other actor. And now that is feeling just wonderful. So now I'm going to save and I'm going to compile. And we can see here that we are getting a notice that our build has failed. And when I go and I read through this error message, we can see that we are converting from an A actor pointer to a Boolean. And that is obviously bad. So what we're going to do here is we're going to have to change our code a bit. The issue is we used destroy. Destroy is a great function, but it is actually attached to the individual actor. So rather than giving the destroy function the other actor, we need to go and we need to use the other actor and we need to call destroy on it. So before what we were doing is we were calling a destroy method and giving it other actor, but this actually doesn't exist. And that's why we got that build failure. But meanwhile, every single actor does have the destroy method, which we can call. So instead of using the destroy method and giving it other actor, we need to use our actor and use the built-in method to the actor called destroy. So let's delete this just to get rid of our comparison point here. And now we'll save, compile, and we can see now that our build is successful, which is great. And now when we hit play, as we approach our first coin here, we're going to interact with it and it's going to disappear. This is fantastic.